All right, let's look at the homework 3.2, problem number 7. All right, so we have a g of x, which is a 9x over e to the x, and we want to find the equation for the nth derivative of g of x. All right, so let's do that. So let's take maybe a first few derivative to see if we can detect a pattern. All right, so first I'm going to rewrite the g of x as, I'm going to actually write it as multiplication. So we have a 9x, all right, then you have, let's see, e to the, all right, since e to the x is on the bottom, so it's going to be a negative power, so we can write it as e to the negative x power, all right? Then we're going to just start taking a derivative, all right? So first derivative, so g prime of x, right? So since 9 is just a constant multiple here, so I'm just going to put 9 in front and then forget about it, right? Then we can just take the derivative of these guys using product rule. So this is our first guy, this is the second guy. So 9 is already taken care of, right? Derivative of the first guy is 1 times second, e to the negative x, and then plus, right? And first guy is x times derivative of e to the x is e to the negative x, then multiply by derivative of negative 1. A negative x would be negative 1, so negative 1, right? And if you clean this up, you're going to get this. You're going to have a 9. Right, then I'm going to just simply pull out e to the negative x here, right? Then you would have, let's see, 1 from here. So we already took e to the negative x, took care of that. So you have 1 here. And then you have a negative x. So it's going to be 1 minus x, right? So we got that. All right, then let's look at the second derivative. All right, so you have a g double prime of x. All right, so it seems like a 9, 9's leftovers. I mean 9's left alone. And then we have this guy times that guy. All right, so we're going to get the derivative. So here, derivative of this first guy would be negative 1. And times the second, e to the negative 1. Plus first guy 1 minus x, and then you have e to the negative x times negative 1 again, right? So if you clean it up, we're going to have 9, right? Then so 9, we take care of the 9, and then we can pull out the e to the negative x and the e to the negative x. So we can put here e to the negative x out here. Right, then we combine them. You're going to have, this is going to be negative 1 minus 1. So it's going to be negative 2. Right, and then we have, so that takes care of this negative, and then negative 1. So you have a negative times negative, so it's going to be plus x. All right, so we have that. And then take another derivative, see if we can start detecting a pattern here. So you have a third derivative. All right, so we're going to leave 9 alone. And then we're going to take the derivative using the product rule again. So this is the first guy, this is the second guy. All right, so we're going to have derivative of the first guy is going to be 1 times the second guy is e to the negative x. Plus first guy is negative 2 plus x, and times the derivative of e to the negative x is e to the negative x times negative 1. Right? So if you clean this up, right, again we have a 9 here. So we're going to put 9. Right? Then both of these guys have e to the negative x, e to the negative x. We can put e to the negative x here. Right, so what's left is going to be All right, so it's so positive 1 plus 2, so that's going to be 3. And then you have a negative x. All right, so seems like we always have 9 in front and always have e to the negative x at the end. And then looks like, first derivative you have 1, second derivative we have 2, third derivative we have 3. So it looks like this is just the same as the number of derivatives, but it actually changes sign. So I'm going to do it this way. So I'm going to write this one. I'm going to pull out the negative sign in front. So you have a negative, so negative sign and 9. Then, so if you pull out the negative 1 from x, you have an x. And then pull out the negative sign from positive 1 is a negative 1. Right? Then you have a e to the negative x. Right? And here, I'm going to simply write it. So this is going to be positive 9. Then you have a x minus 2 e to the negative x, right? And then after that, and so it looks like a sign alternates, negative 9, and then x minus 3 e to the negative x, right? So we can probably detect the pattern here. So if you're taking the nth derivative, right, of g of x, right? All right, so it's going to depend. So you're gonna have an alternate sign. So in order to have an alternate sign, easy way to do that is you can have negative 1 to the nth power. So that means that if n is even, it's going to be positive. N is odd, it's going to be negative. Right? Then everyone has 9. Right? So everyone has x. And everyone has minus, right? So first derivative is 1, second derivative is 2, third derivative 3. So nth derivative it would be x minus n. Then everyone has e to the negative x, right? So that would be the formula, right? So let's type it in. Right, so we would have negative 1 to the nth power, right? 9 times x minus n e to the negative x. All right, let's check the answer. All right, I came back and looks like we got the formula correctly. All right, that's it. I hope that this was clear.